if you read what people wrote in the early 1960s, including lots of people at MIT, about what was going to happen, how we were just a transient species that were, producing the next great thing that was going to be AI. The things that you read there are basically identical to what people say today, with the small exception that there was a different, there wasn't the same kind of, there was poor political correctness, let's say, back then about various kinds of things. That's the only way you can tell when those sentences were written, is that it didn't have some of the modern sensibilities. So people have been talking about this for a very long time, and the question is, what? It's a reasonable question. What happens when, this question of we have machines that are capable of doing things that we can't do, and so on. Where do we fit into all of this? And I think the thing to understand is that, sort of left to their own devices, the machines have they just make sort of random computations. It's not, we have to define what it is we want from them. So, for example, look at the natural world. We make use of the natural world to produce technology that we care about. The natural world keeps going and doing what it's doing, independent of us making use of it and us kind of, connecting with it. And I think that's, a thing to talk about, for example, jobs humans do. You go back to the 1850s, for example, in the US, most people were doing agriculture. Most people needed to actually work on, growing food. That got automated. Then, the pie chart of what jobs people did went from being dominantly agriculture to being a much more fragmented collection of different things. It seems like it's a general phenomenon that as more gets automated, what happens? It's not that jobs go away, it's that the diversity of jobs that can be done increases. And I think that's, and I think what's happening is a lot of the time, many more things are possible, and then humans have to choose which of those things they actually end up doing. I think, you see that a bunch with in a lot of areas, things have become very easy to do. So there are many different possible things that can be done, and then somebody has to choose, which generative AI picture to make and so on. Whereas before, it was like to make any picture was difficult. So I tend to think that what happens is that as we automate more, we have a wider range of things we can do, and we humans have to get to decide which of those possibilities we pursue, and that will never be automated, because which things we choose to pursue it's not something that is in principle automatable. I have to bring up one picture, which actually I had brought up before for a completely different reason, but I think it's perhaps fun to look at this. Let me see if I can find it. Okay. I'm ignorant of that. This was just a picture of it's sort of a mind of an AI type picture. So it's a generative AI model producing images, and in the center is what you get if you say make a picture of a cat in a party hat. And then what's away from the center is kind of different sort of small variations of the internal embedding representation of what it is supposed to be a picture of. Okay, what's relevant about this? You see in the center this kind of cat island of things that look like cats. You go away from that. These are all images that the AI can kind of imagine, but they're mostly things where we humans just look at them and you say, I don't know what that's a picture of. It's clearly got some structure, but I don't know why it's important. One thing you can ask is, in the space of all possible images the AI can make, what fraction of them correspond to concepts that, for example, we have words for? We have like 50,000 words in typical languages. How much of the space of possible images are captured by words that we have? The answer, even in this very simple model here, is 1 part in 10 to the 600. So the vast majority of the space of possible images is what one can kind of call interconcept space of images that are between human concepts. And so, but the question is, well, are some of the things that you see here, will it be the case that at some point in the future somebody will say, that's a really cool picture, it's a style of art that we call such and such a thing, and then we will expand the domain of sort of what counts as concepts as opposed to this kind of undefined interconcept space. And I think that there's just kind of a realization that what we humans have chosen to think about is a very small fraction of what's out there and is possible. And I think that's, this question of where do we choose to go is something that is completely arbitrary human choice. And, there's no right answer to we should go in this direction or that direction. It's just this is the direction we happen to sort of historically be going in. Anyway, a few thoughts about that. Please, yes. Yes, I've been a little bit surprised by how well it's aged. Yeah, I was wondering about that. Should I make I wrote a little thing which turned into a book that called What is ChatGPT Doing and Why Does It Work? Which I wrote because basically after ChatGPT came out, just a zillion people asked me basically those two questions. So I thought I'd better sit down for a week and actually write what I know about the answers to those questions. And that was partly just a description of kind of the basic idea of sort of machine learning and AI and so on, together with some theories about kind of what was going on that I actually was mentioning earlier here about semantic grammar of language and so on, about sort of what regularities ChatGPT had found. Yes, I was wondering, should I make a revised version? And actually, I agree, there's very little has changed. Now, what does this tell you? It tells you that what's happening is something that's very typical in the development of both science and technology. There's a methodological advance, there's a big sort of jump in capability, there's a bunch of low-hanging fruit to be picked, and then things get hard, and there's a long period of time where there's only incremental progress. I mean, it's notable that, for example, the advances in image recognition around 2011, 2012, image recognition today isn't much better than it was in 2011, 2012. It's been very incremental progress. There was one kind of period of breakthrough, and then it's been sort of incremental. And I think that's what, I suspect that's what we're going to see with a lot of kinds of things that happen with AI. I mean, I think one thing that will happen is there are different domains where AI will be successful. The one that I'm predicting in the fairly near term is kind of a ChatGPT moment for robotics, which I think is coming. We'll see. I don't know which year. It's always very hard to predict which year these things happen. But that seems like a thing where, being able to fluently do the kinds of, motions that humans do and so on, that will come. Just as the surprise for all of us was that, it was possible to make, fluent text, that came in 2022. But yes, it is a little bit telling that that there's not much more to say. I mean, one could talk a bit about chain of thought kinds of things, but I don't think that's really, it's not changed the core ideas there. I do think that the one thing that is notable that we learn from neuroscience is, us humans have the feature that we learn and we think at the same time. As we think, we learn, so to speak. That's not traditionally been typically the case in AI systems. There's the training phase, and then there's the inference phase, the thinking phase, so to speak. Those two things probably, and there's reinforcement learning and so on that tries to mix them. But I suspect there might be some breakthrough along the lines of more finely mixing those things. The other thing I'm certainly interested in is how do we mix kind of computation and symbolic kinds of things with the kind of neural net level of things. And I think there may be some good breakthroughs in kind of more fine-grainedly connecting. I mean, right now, you run the LLM, it generates, with our computational augmented generation mechanism, it's basically generating what amounts to, and now I want to use this tool to do this particular thing, and then you get the results from that and it goes back to the LLM. But there's the question of whether you can have a more fine-grained version of that. If we'd had experience as humans with like neural implants, we might have a better idea about this. Because, if you imagine some neural implant where as you're thinking, you get to access some computational capability, we just don't have intuition about what that would be like. At least I don't have intuition about what that might be like. And that's the kind of thing, right now, our sort of implants into LLMs are mostly along the lines of the baton is being, carried by the LLM, and then it's being given to the computation system, then it's being given back again, rather than something more fine-grained. Let's see, over here, yeah.
I'm trying to connect some of the ideas from earlier, and it's actually related to what you're saying right now. You were talking about irreducible code, right? And you were also talking about the representation of these network structures as cellular automata. It seems like the implication is that we have certain irreducible pieces of code that have been very successful at identifying the semantic structure of language, and that's what's given rise to ChatGPT. Do you think that there are other irreducible blocks of code that we could be using for something that is outside of language? You talked about robotics. Where do you see potential for what else we could be building? And do you think that that requires us to rethink the model, the connectivity of this cellular automata?
Well,
Equivalent?
I don't know. I think this whole question about, where are places where that you can sort of make computational that haven't been before. I mean, I've spent a large part of my life trying to have sort of computational representations for different kinds of things. It's been surprising the extent to which one can make computational representations of things. Like, for example, human senses. We have good computational representations of images. We have good ones of sound. We don't have such good ones of, taste and smell and things like this. Those are types of things. I was just talking to somebody about the representation of sort of 3D geometry as another kind of thing that you can imagine working with. I mean, each of these different modalities will surely have there'll be a sort of a that either has been or will be sort of a ChatGPT moment, I suspect, for one. But they're always for ones which have some human connection, because they're ones where it's like 3D geometry as we want to use and think about 3D geometry. It's not arbitrary 3D geometry. It's because I think the reason is that neural nets are a bit like us. Their architecture is similar to ours. The kinds of things that neural nets do well are similar to the kinds of things that we humans do well. If you present us with sort of an arbitrary thing that is, an arbitrary structure that sort of can be made abstractly, computationally, mathematically, or whatever, there's no reason to think the neural nets will do well, just as there's no reason to think we humans do well. The thing that makes it more relevant that we can do things that humans do well is that the things that humans do well typically are the things that humans care about. I mean, an example, if you say, just using this example with someone else, so if you talk about clouds in the sky, you say, what's the shape of that cloud in detail? Nobody really cares much about that. There's some classification of the general shapes, but if you ask about the details of that, just isn't something that we've really focused on. We could, but we haven't. And that's, whether that is something that is amenable to being thought about by a neural net or a brain, I don't really know. But the things that the things that we make use of are things that with brains with architectures like ours, we're able to deal with. If you imagine, for example, we had much bigger brains with more neurons and things, maybe there will be different things that we could make use of, but that isn't where we are right now, so to speak. I don't know if that was responsive to what you were asking, but
I think it is. It's no longer a question, but just a thought. I think you're right that it's the things that we're good at, but it seems to me like very often the big advances in thinking come from moving away from how we're used to thinking. And maybe that's one way that we can use
sure.
AI to push us to get out of that usual way of thinking.
Right. I mean, the thing is, people say, it's going to be amazing if AI is original, creative, whatever else. It's trivial in the computational world to be original and creative. What's non-trivial is to connect what happens to things that we humans care about. I mean, looking at these pictures, every image is something kind of creative, but most of them are not images that we say are terribly significant to us. So, the way I see it is there's a sort of gradual expansion of human civilization or something. We gradually expand to sort of understand more of this kind of space of possibilities. And we decide that this is a branch that we're going to, that we're really going to care about. And it's a gradual process. If you plop us down, I mean, I've spent some large part of my life kind of studying the science of the computational universe, a large part of which is you just sort of, you teleport yourself to some random place in the computational universe, you generate some picture of some behavior, you look at it, and you say, I don't know what's going on here. This is something that doesn't really connect to anything that I know about. Yes, please.
You said something last year that really struck with me. You talked about how what ChatGPT was really doing was it was finding a symbolic representation in language that we hadn't found previously. You described how one of the reasons you built Wolfram Alpha is because you already had a symbolic representation for mathematics. And you expressed the hope that there would be more abilities to connect up those two symbolic representations. Have you seen any progress in that area? And do you expect to see progress for more integration between those as opposed to the baton handoff you're describing today?
Yeah, I mean, well, we made a lot of progress in the actual practical technology of having LLMs interact with our computational language. I mean, the language, Wolfram language that we built is unique in the sense that it's a language that is trying to represent things in the world. It's not a programming language that's just representing stuff going on inside a computer. It has, built-in representations of, cities and chemicals and movies and all these kinds of things. And so that's been a kind of a long time thing to build sort of this computational representation of the world. And what we've done more recently is to make it so that the LLM can more easily interface with that kind of computational representation of the world. And it works really very well. I mean, you can say something surprisingly vague, and it will be turned into a definite piece. So this is sort of a workflow that we've seen emerging. You imagine what you want to do. You describe it in a fairly vague way to our notebook assistant, for example, and then it will generate, through this computational augmented generation mechanism, it will generate a piece of Wolfram language code that is something you can read. You look at it, you say, well, that wasn't quite what I meant, but let me change it in this way or that way. And then you have this sort of solid block of code that you can then build from and use in other places. And I think that workflow of you say something vague to the LLM, it kind of crispens it up, turns it into something you can represent computationally. Very important in our language that it's a language that can be read by humans as well as written by humans. And then you kind of iterate at that level, you get this lump of computation that you can then go and use in lots of places. Now, in terms of this question about sort of the things that ChatGPT showed us exist, like these symbolic representations of more things in the world in terms of language and so on, actually we've been making quite a bit of progress on that and have not yet had things that we are ready to demo to people, but it's a project I've been interested in for a long time. I call it our symbolic discourse language, although it may yet get a different name. But basically, the purpose of that is if I say a sentence like, I want to eat a piece of chocolate, okay, we have a very good representation in Wolfram language of a piece of chocolate. We know about all the different brands of chocolate and their nutrition content, all that kind of thing. We don't have a good representation of the I want to eat part of it, but we've been building such a thing. And what one ends up doing is to build this kind of symbolic version of that where you have all these little calculi about the way the world works based on that symbolic representation. So, for example, if I eat a piece of chocolate, then one of the things I can conclude is that piece of chocolate is no more, so to speak. The piece of chocolate is gone, it's been consumed. And so then we can make these sort of calculi about what happens in the world. We can then ask questions about, well, where is that piece of chocolate? Well, it's gone, type thing. And anyway, we've been building this up by using LLMs to help us and using what we've learned about language design and kind of going back to things that people last tried to do this project basically in the 1600s. There was this whole effort to build a philosophical language, and that was kind of the this is sort of a picking up on what was left off by people in the 1600s, which is a very long delay. But anyway, we've been making good progress at that. I don't think, and it's quite interesting when it comes to robotics, for example. One of the things that I think is going to be really interesting there is to have a high-level language to describe what it is roughly you want a robot to do, not move the arm in this particular way, but make a general statement about what the robot should do in a precise language that it can then translate into the particular motions it's going to go through to do those things, and then you can change what you tell it to do, and you're basically writing a high-level program that describes what you want.
If I were to replace a neural network with a cellular account, what would you say would be the backpropagation?
Okay, so how does backpropagation work? So it turns out that the simple thing to do is just make mutations, right? In other words, instead of saying I know what the error is at the end, and let me sort of propagate that back and change the weights, just make random mutations to the weights. And if the mutation is beneficial, keep it. If it isn't, throw it away. That's a very minimal approach. And you might say that couldn't possibly work. But actually, it does work quite well. Now, with backpropagation, you can say, let's go from the error and propagate backwards. You can make a Boolean analog of backpropagation. I described that, actually. It turns out that whereas backpropagation in ordinary calculus is unique, that is, the inversion of the chain rule gives you a unique answer, Boolean backpropagation is not, the inverse is not unique. It does not have a single inverse. So you have this choice. You can either just do mutations, sort of forward mutations, or you can do Boolean backpropagation. But with Boolean backpropagation, there's kind of a zero. Okay.
Yeah.
You never know what's going to happen with the John Werner event. Okay, thanks, guys.